This week on the show, we have Unix virtual memory when you have no swap space discussions, Dsynth details on Dragonfly BSD and what that is. We cover a little bit of the instant workstation on FreeBSD. We also cover new servers, new tech, and the benefits they bring for Dragonfly BSD. We also tell you a little bit about experimenting with streaming setups on NetBSD that you can do. Streaming is interesting, but Steam is also interesting, with NetBSD's progress towards that in the Google Summer of Code that finished recently, and more in this week's episode of BSD Now. BSD Now, episode 314, aka episode Pi. Swap That Space is the title, and it was recorded for the 4th of September 2019. Hello, I'm your host, Benedikt Reuschling. Welcome to this special episode we have hit some kind of special episode number, as our show editor points out. Yeah, well, we only get these once in a while, so we kind of make that happen. But what everyone is waiting for, of course, are the headlines for this week, and it starts off, what has to happen with Unix virtual memory when you have no swap space?
So this is another post on Chris Seiberman's blog over at the University of Toronto, and he says, recently, Artem S. Tashkinov wrote on the Linux kernel mailing list about Linux problems under memory pressure. The specific reproduction instructions involved having a low amount of memory, turning off swap space, and then putting the system under load, and then this would happen. Once you hit a situation when opening a new tab requires more RAM, I'm guessing they mean in a browser, than it is currently more RAM than is currently available, the system will stall hard. You will barely be able to move the mouse pointer. Your disk LED will be flashing incessantly. I'm not entirely sure why. So he says, I'm afraid I have bad news for people snickering at Linux here. If you're running without swap space, you could probably get any Unix to behave this way under memory pressure. If you can't on your particular Unix, I'd actually say that your Unix is probably not letting you get full use out of your memory. To simplify a bit, we can divide pages of user memory into anonymous pages and file-backed pages. File-backed pages are what they sound like. They come from specific files on the file system, and they can be written out if they're dirty, meaning they've been changed, or read back in if they aren't being used. Basically, if you have a file-backed page and it hasn't been changed, then you can free that memory, because if somebody comes looking for that memory again, you can always read that file again. If it's dirty, meaning you've changed the copy in memory, most times it means you could write that update to the file and then throw it away, because again, you'll be able to read it back. Anonymous pages are not backed by a file, and so the only place they can be written out and then read back is swap space. So if you don't have any, then there's nowhere they can go. Anonymous pages mostly come from dynamic memory allocations and from modifying the program's global variables and data. File-backed pages mostly come from mapping files into memory with mmap, and also crucially from the code and read-only segments of an application. Right? If it's the actual code of the application, you can usually again read that in from the binary on the disk. But a file-backed page can turn into an anonymous page under certain circumstances, like if you're doing copy on write with mmap and so on. Under normal circumstances, when you have swap space and your system is under memory pressure, a Unix kernel will balance evicting anonymous pages out to the swap space with evicting file-backed pages out to their source file. However, when you have no swap space, the kernel cannot evict anonymous pages at all. They're stuck in RAM because there's nowhere else to put them. All the kernel can do is reclaim memory, or to be able to reclaim memory, is to evict whatever file-backed pages there are, even if these pages are going to be needed again very soon, and will have to be read back in from the file system. So if RAM keeps getting allocated for anonymous pages, there is less and less RAM left to hold whatever collection of file-backed pages your system needs to actually do useful things. And your system will spend more and more of its time thrashing around reading file-backed pages and making your disk LED light blink like crazy. Since one of the sources of fileback pages is the actual executable code of all of your programs, and mostly their shared libraries and so on, it's quite possible to get into a situation where your program can barely run without taking a page fault for another page of code. So if you're using a lot of anonymous memory, your system's going to slow to a crawl because you're going to keep evicting the memory containing the program you're trying to run in order to make a dynamic allocation or whatever. And so it's going to have to, read some of the program, run a little bit, throw that out, read the next part of the program, run a little bit, throw that out, and you're going to be constantly reading in off disk. This is why we have swap. So we can swap out the least active data, even if it's anonymous, so that the active data, which might be the program you're trying to run, can stay in memory.
So that's good to have always, no matter how much memory you have.
And it says, this frantic eviction of fileback pages can happen even if you have anonymous pages that are being used only very infrequently, and so would normally be immediately pushed out to swap space to give you more breathing room. With no swap space, anonymous pages are stuck in RAM no matter how frequently they're being touched. The only anonymous pages that can be discarded are ones that have never been written to, and so are guaranteed to contain nothing but zeros. In the old days, this usually was not very much of an issue because system RAM was generally large compared to the size of the programs and thus the amount of fileback pages that were likely to be in memory. That's no longer the case today. Modern large programs like Firefox and shared libraries can have significant amounts of fileback code and data pages, in addition to their often large use of dynamically allocated memory, or anonymous pages. In theory, this thrashing can happen in any Unix. To prevent it, your Unix has to decide to deliberately not allow you to allocate more anonymous pages after a certain point. Even though it could evict fileback pages to make room for more anonymous pages, deciding when to cut your anonymous allocations off is necessarily a heuristic, and so any Unix that tries to do it sooner or later is going to prevent you from using some of your RAM. This is different than the usual issue with overcommitting virtual memory address space because you're not asking for more memory than could theoretically be satisfied. The kernel has to guess which file-backed memory pages you will need in order to perform decently, and it has to do so at a time when you're trying to allocate anonymous memory since you can't take the memory back later. So it has to decide when you allocate the memory, not when you're actually doing stuff with it, because then because there's no overcommit. That's why not having swap is usually not a great idea.
Yeah.
Even just a little bit can make a big difference.
And you have the disk space for it usually, so...
And I know some people are like, well, I don't want to burn up my SSD on swap. And it's like, well, it's not going to burn it up that much. And having even just a gig of swap can make a really big difference of getting some of those not really being used for much at all anonymous pages out of the way so that you can keep some decent amount of your fileback pages in memory.
So that's a good reminder to think about swap and not having it completely zero. And you can always create swap files if you've got to do that. And you can use files. It's not ideal in certain cases, but at least you have some swap in files this way. Okay, so much for swap. Next up, we have Dsynth details on Dragonfly. So this is a short post, but it has a couple of links into further details. So first, the history. Dragonfly has had binaries of D ports, Dragonfly ports, available for download for quite some time. These were originally built using Poudriere and then using the Dsynth tool put together by John Marino. Dsynth worked both to build all software in D ports and as a way to test Dragonfly's SMP capability under extreme load. And Matthew Dillon is working on a new version, there's a link there, called Dsynth. It is available now, but it's not yet part of the build. He's been working quickly on it, and there's plenty more commits than what they have linked here. And it's already led to finding some high load fixes. It's an interesting thing when you put your system on the load, what kind of issues it might entail.
So Dsynth is basically a re-implementation of Synth, which is written in Ada, but Dsynth is written in C.
Yeah, from scratch, so that's completely new. It is designed to give us a bulk builder in base and be friendly to porting and jails down the line. For now, it uses change roots, so that's a separate environment there. The original Synth was written by John R. Marino, and its basic flow was used in writing this program, but as it was written in ADA, as Madeline mentioned, no code was directly copied. The intent is to make Dsynth compatible with Synth's configuration files and directory structure. And this is a work in progress and not yet ready for prime time. Pushing so we can get some more eyeballs, so people can test. Most of the directives do not work yet. Like everything in build works, and cleanup can be used to clean up any dangling mounts. So people can check that out on GitWeb, dragonflybsd.org, and provide fixes, testing, feedback to make Dsynth more ready, I guess, for inclusion or being used. So yeah, that's an interesting development there. And again, if you put a system under pressure, you might discover certain new things that that you didn't know before on the light load, and that leads to patches and fixes so that it can also handle the high loads. It's now time for the news roundup this week. We have our first item about the instant workstation.
Yep, this is from Adrian de Groot, who works on KDE and stuff on FreeBSD.
Oh, yes, yeah.
And he says, instant workstation. Some considerable time ago, I wrote up instructions on how to get a FreeBSD machine with the latest KDE Plasma desktop. Those instructions, while fairly short, set up X, install the KDE Metaport, and that's it, are a bit fiddly. So, prompted slightly by a Twitter exchange recently, I've started a mini sub-project to script the installation of a desktop environment and the bits needed to install it. To give it at least a modicum of a UI, he used the dialog system to ask for an environment to install in a desktop manager. The tricky bits, pointed out to me after I had started, is hardware support. Although best effort is better than having nothing. Yeah. In any case, in a VirtualBox host, it's now down to running a single script and picking between Plasma and SDDM to get a usable system going. Other combinations have not yet been tested, nor have system hardware setups. I'll probably maintain it for a while if I have the time and energy. It'll be tried with NVIDIA, which works quite well with FreeBSD, and AMD. Not so much currently, but is getting much better with the DRM work. So there's a link to the script in his GitHub repositories with some notes for himself in there. Installing FreeBSD is not like installing a Linux distribution. A Linux distribution hands you something that will provide an operating system and more, generally with a selection of pre-installed packages and configurations. If you look at Arco Linux, it offers 14 different ISOs depending on your preference of installed software. FreeBSD doesn't give you that. You end up with a text mode prompt. There are some FreeBSD distributions like TrueOS and so on, or Project Trident, that have these extra bits, but those are kind of outside his normal field of view. So it's not really expected that you will have a complete desktop experience post-install, nor for that matter is complete GitLab server or a postfix mail relay or any of the other specialized purposes. He says, I could vaguely imagine bungling this up into the BSD install as a post-installation option, but that's certainly not my call. Not to mention, I think there's an effort ongoing to update the FreeBSD installer anyway. So to sum it up, to install a FreeBSD machine with KDE Plasma, you can just download the script and run it.
Hey, cool, yeah.
Yeah, it looks pretty straightforward. I had something not too different sorted out as a small patch to the installer of just choosing between KDE, GNOME, XFCE, and Mate, I think.
Oh, yes, yeah, so that people have a desktop after the installation, not just a shell.
Yeah, and it ended up looking very, very similar to this code, actually.
Mm-hmm.
But the problem I was having was the options of login managers were not very good at the time. They've gotten much better since, now that there's SDDM and so on. Basically, the option for a bunch of them was PCDM, which if you have the wrong version causes problems, or Slim, which didn't seem to work. But it looks like there's better options now.
Yeah, so people can build that and have something more than just a shell after the installation, which is fine for most server types. But if you want a little bit more, then check that out.
Yeah, it's like, when you install it on your laptop and you finish, you're like, oh, that was a nice quick install. And then you're like, oh, I'm not finished yet.
Where's the rest? Yeah, but for a server, this is definitely too much, or you don't want to run a desktop environment there necessarily. But for the laptop types, definitely have something like that. Okay, next up, we have new servers, new tech, new story from Dragonfly Digest. So they followed up on an earlier post with the new servers for Dragonfly are being in place now. The old 40-core machines used for bulk builds, the Monster called, is being retired. The power efficiency of the new machines is startling. Instantly, this is where donations go. Infrastructure. Who would have thought? Yeah, this is also important for a project to have.
3 new servers have been installed in the Dragonfly colocation and are taking over almost all of the bulk package building from the older machine's Monster, which is being retired, and 2 of the old Blade servers called Muscles and Packagebox 64. The new servers are a dual socket Xeon called Sting and a pair of 3900X based AMDs named Thor and Loki, which altogether burn only about half the amount of power as Monster did. So while Monster took 1,000 watts, these 3 machines only take 500 watts and provide more than 3 times the performance. So that gives at least a 6-to-1 improvement in performance efficiency. With SSD prices down significantly, the new machines are also all SSD. These new machines allow us to build deep port binary packages for releases, the master branch and the stage branch at the same time, and reduce the full-on package build times for getting all 3 done from 2 weeks down to 2 days, which allows us to more promptly synchronize updates to ports with deports and get binary packages out to everyone sooner. So Monster, their venerable 48-core quad socket machine, is being retired. This was a wonderful dev machine for working on Dragonfly's SMP algorithms over the last 6 years because its intercore and intersocket latencies were quite high, so it was easy to see the differences. If an SMP algorithm wasn't spot on, you could feel it. Over the years, Dragonfly's performance on Monster is doing things like bulk builds increased radically as the SMP algorithms got better and better, and the cores became more and more localized. This kept Monster relevant far longer than I would have thought it would have been. But we are at a point now where improvements in efficiency are just too good to ignore. So Monster's quad Opterons, that's 4 sockets, each with 12 cores, pulls over 1,000 watts under load, while a single Ryzen 3900X, which provides 12 cores and 24 threads, in a server configuration pulls only 150 watts and is slightly faster on the same hardware slightly faster to do the same amount of work. So doing the same amount of work for a lot less power and with half as many threads seems to be a big improvement. So we'd like to thank everyone's generous donations over the last few years. We burned a few thousand on the new machines, as well as the SSD updates, including upgrading the SSDs in the blades. We made very good use of the money, particularly this year's, as prices for all major components like RAM, SSDs, CPUs, and motherboards has dropped significantly.
Yeah, so a couple new machines, more and quicker builds, and more power efficiency. Definitely good to have. So don't keep those old servers running too long. There's new stuff around. And again, these were mostly financed from donations, so the infrastructure for the project. So that's one way where you can see where the money goes and what they're using it for. And it's not just Dragonfly, it's similar with donations to the FreeBSD Foundation, for example. Some of that is also going into infrastructure, new servers, better built servers, different regions. So this is one use, not just the only one, but a good example for it. Okay, next up, we have something that we covered a little bit before in an earlier episode, but this is a nice follow-up. Experimenting with streaming setups on NetBSD. And here's already a little setup here, a little picture here for the people watching the stream, or clicking on the link in the show notes. So that was successfully ported to NetBSD. It's been trying, or the author here is trying it out, seeing what works and what doesn't. He's only just gotten started.
Nope, she.
Oh, she, sorry. Yeah, didn't get that.
I can't remember her name. She presented at MeetBSD about video games in one of the lightning talks.
Oh, right. Her. Yeah, I remember her. Okay, sorry about that. So,
Just don't remember her name.
Yeah, she did some work in the gaming area, wasn't she?
Yeah.
Mm-hmm. Okay, then it's the right person. Okay, so she's only got us just started, and definitely is going to be a lot of tweaking going forward. Oh, see that nice little keyboard? That reminds me of Tom Jones' keyboard. He has a similar one with multi-key or multi-dimension keys. But that's beside the point. Capturing a specific application's windows seems to work okay. That's what you want to use in OBS, of course. Capturing an entire display works as well. And she actually hasn't tried streaming to Twitch or YouTube yet. But in a previous experiment a few weeks ago, she was able to run an FFmpeg command line, and that could stream to Twitch mostly okay.
Yeah, it should just work.
Oh, you've tried that yourself as well?
Yeah, FFmpeg sending to Twitch or YouTube or whatever is fine because FFmpeg is quite good at putting out an RTMP stream.
Excellent.
Basically, the scale engine stuff in the back end works the same as Twitch or YouTube. And so I know that we do it a lot, including we actually can take a stream it, but also send a second copy of it off to YouTube using the same mechanism.
Oh, see? Very well. Excellent. Her laptop, combined with the external monitor, allows her to have a dual monitor setup wherein the smaller laptop screen can be her broadcasting station, while the bigger screen is where all the action takes place. She can make OBS visible on all XFCE's workspaces, but keeps it tucked away on that display only. Altogether, the setup should let her use the big screen for the fun stuff, but she can still monitor everything on the small screen. Yeah, so that's good to control whether you are still broadcasting or something's wrong.
Yeah, or seeing the preview and so on. Yeah, we use OBS extensively at Scale Engine for testing and stuff. It's very nice to have that on BSDs. For FreeBSD, a big thanks to Chris Moore for doing the original port. I'm not sure who maintains it now, but I know Chris got it working for me originally.
Oh, cool. Shout out to you, Chris. And yeah, I see a couple more BSD streamers starting their streaming careers now. Next up is also a NetBSD story. NetBSD made progress thanks to Google Summer of Code in its march towards Steam support. Oh, now you can stream and do Steam. So you can stream the latest Steam games, I guess. Wow. Okay, but one thing after the other. This is, Veronic's story. So they write, ultimately, the goal is to get Valve's Steam client running on NetBSD using the Linux compatibility layer, while the focus on the past few months with Google Summer of Code 2019 were supporting the necessary DRM ioctls for allowing Linux software running on NetBSD to be able to tap the accelerated graphics support. Student developer Surya P spent the summer working on compat_NetBSD32 DRM interfaces to allow direct rendering manager using applications running under the Linux compatibility layer. These interfaces have been tested and working as well as updating the SUSE 131 packages in NetBSD to make use of these interfaces. So the necessary interfaces are now in place for Linux software running on NetBSD to be able to use accelerated graphics through Steam itself. Though Steam itself isn't yet running on NetBSD with this layer. Okay, so those curious about this DRM ioctl GSoC project, they can learn that from the NetBSD blog. It's linked there. And NetBSD has been seeing work this summer on the Wayland support and Better Wine support as well to ultimately make this BSD a better desktop operating system and potentially a comparable gaming platform to Linux.
Yeah, the Wine support stuff is especially interesting because, it opens up a lot more options.
It's fairly straightforward, I guess, or it can at least looked into, that the other BSDs can grab some of that code and use it on their systems as well. So great, yeah, this is a nice turnout from Google's Summer of Code this year for NetBSD and some others. So yeah, congratulations to the students, and the gamers are also happy now.
Yeah, we should do a rundown of all the BSD's projects in an upcoming episode. I know there was one of the interesting ones just posted its report to the FreeBSD mailing lists. I haven't actually had time to read it yet, but I did see that it was there.
Yeah, we'll keep it in the back of our heads so we can come up with a little show item for the future. Time for Beastie Bits this week. The first item is FreeBSD in Wellington, ? That's Wellington, New Zealand, I guess.
Yes, so this is my mentee, Thomas Monroe, who's been is a Postgres developer, but has also been working on FreeBSD to improve the integration between the two.
And he tweets, Any FreeBSD users/developers in Wellington, New Zealand? A couple of us are trying to put together a small group to meet up. Please ping me.
Yeah, so if you happen to be in Wellington, New Zealand and want to meet up with other BSD people, please get in touch with Thomas, and I hope you guys have fun.
Yes, having people with a similar interest close by, talking to them, is definitely good. You never know what kind of new people you meet, and it's certainly a fun event, having people around that you can talk all kinds of geeky BSD stuff. That's why we go to these conferences so often this year, or last. Okay, the next item is FreeBSD on GFE, also on Twitter. Ruslan Bukin is posting that. There's success here. FreeBSD is up and running on the US government furnished equipment called GFE 64-bit RISC-V cores. GFE cores are synthesized on the $7,000 Xilinx VCU 118 unit. Soon, all the voting machines in the US will be powered by FreeBSD/RISC-V. There's a little board picture.
There's a small update to that one saying that this is a DARPA-funded, DARPA isn't actually building a voting machine for widespread use. Instead, one of their contractors, called Galios, is prototyping a voting machine using DARPA-funded components, which means using the Cherry RISC-V processor, which is why Ruslan is working on it and getting FreeBSD running. There are no plans to manufacture these at scale or deploy them in real elections yet, just testing.
But yeah, it's definitely a success for the platform bring-up, and I mean, the $7,000 machine isn't too bad.
Well, so the $7,000 machine is an emulator pretending to be a RISC-V chip that doesn't actually exist yet.
Oh, it's not the hardware yet. Okay.
But it's pretending to be the hardware. It's basically using an expensive FPGA to simulate the hardware that doesn't actually exist yet.
Okay, so it's close to the metal, the future metal that's been coming out in the future.
Yes, it's a simulation of the real metal.
So yeah, if you have that working in the emulator, I guess the real hardware will be similar enough to make porting easy enough for the last bits that are different. Very nice. Yeah, so congratulations on that work. And I guess RISC-V will hear more about this in future years because it's an interesting architecture and open. Okay, there's the clarification we read already, and we have a new item here, distrotest.net, now with BSDs. This is over at distrotest.net.
Yes, which basically just seems to be a giant alphabetical list of operating systems for people that like to distro hop, and they now include a bunch of the BSDs. It's interesting to see the distribution of Linux distros by letter of the alphabet.
Yeah.
And there's only one on this list that starts with the letter I. They should add a Lumos. I guess a Lumos isn't a distribution, though. You can't actually just download and run a Lumos. So.
Yeah, there's all kinds of variations, of course, from a base operating system, like a graphics, Kubuntu, Ubuntu, Ubuntu. But the FreeBSDs and the OpenBSDs and the NetBSDs of this world are in there as well. And so these are basically links to the home pages of that, or is that a more closer description?
Oh, okay. So this website is different than I thought it was. It actually lets you try these systems.
Oh, System Start. There's a button. Excellent.
Yes.
I always wanted to run, let's see, what's this FreeBSD thing I hear so much about?
Ah, yes. Okay, so it fires up a no VNC client, and you actually boot into the operating system.
Oh, so they're running somewhere, and you just get the shell?
Yes. So they have like so many VM slots available, and you can fire up an OS for up to 30 minutes. And if you keep clicking once every 15 minutes, you can extend your session, and you can actually try out the different distros before you download and install them. So this is actually really cool. So if you've ever wanted to just see what it looks like to have the command prompt on FreeBSD and go through the installer and so on, you can actually try it out on this website for a little bit before you even download it. That is cool.
Yeah, just give it a little bit of a whirl and see if the commands are doing the same thing as you're used to. I see. That's a nice idea. We are hosting 756 versions with 236 operating systems at the time of this recording. Ooh. I even like the subtitle there. Test it before you hate it. Okay, so people can now have a look left and right what the Unix space has to offer. And there's a lecture here from the Chaos Communication Camp this year in Germany, I hear. I mean, I hear these things after they're done mostly.
Same here. CCC ended on Sunday, and it's Wednesday now. But yes, the speaker here gave the talk, the battle of making the NetBSD better software by leveraging any kernels. NetBSD offers the rump any kernel, which lets users to do magic and execute drivers, network stack, or file systems in user space. Having kernel parts running in user space is a great opportunity to fuzz them efficiently without fancy kernel approaches. The first general information about rump will be discussed to get the audience familiar with the subject. Then results in focus on testing network stacks can be presented along with encountering problems and other fuzzing efforts that are currently taking place in the NetBSD project.
I didn't know they had a NetBSD or a fuzzing talk there. I should have looked at that more closely to the whole camp. I know that at least Tom Jones was there at the camp.
Maybe just got back or not actually got back from Taiwan yet at that point. So
yeah, that could be. Yeah, it was overlapping with that travel. Oh, next up is also interesting. We have a business plan from 1982, but it's for Sun Microsystems. It's a PDF. So their originally idea, so you basically create a business plan to go to a bank and tell them about your future business that you try to build. And this is helping them to convince it, I guess.
So their mission was to develop, manufacture, market, and support graphical workstations for OEM CAD and CAM marketplace. Evolve a family of compatible graphics workstations, lead with the best cost performance product on the market. So their objective for the first 4 months from February to May of 1982 for their product was to bring the product to market, make first customer shipments of the Sun workstation by May 31st, define a product family for the OEM market, including enhancements, options, and software for OEMs, begin development and distribution of a Unix operating system. Assemble a team of people to lead the company through its rapid growth, recruit high-level marketing and software expertise. And then the following pages contain a preliminary business plan designed to present the overall picture. A full operating plan and budget will be worked out by May 31st. And then estimates for seed funding are outlined in Appendix B. The objective is to obtain seed money in February and full funding by May. And then they have a tentative 2-year plan.
And yeah, looking back now, it seems like they were successful with that early plan. I mean, you always make a plan and then deviate a little bit, but failing to plan is planning to fail.
Yeah, so their seed funding plan was to get $250,000, which I guess in 1982 dollars is quite a bit of money, and to have enough money to build 20 systems that they could then sell.
Yeah, as a first estimate what the market might get. Oh, see, there's also Appendix C with a lot of handwritten stuff.
Engineering development required a mouse and keyboard.
Yeah, well, it needs to have some input.
We'd need 10 megabit Ethernet transmitters. Or transceivers.
Yes, yeah, you have to start small. It's 1982.
Yep.
Distributed Unix, networking software, graphics software, Unix, single user / whatever, distribution, and then a file server. Yeah, kind of important. Text editors, graphics editors, benchmarks. So in case you're planning to start a business, this might be a good start or at least a cheat sheet of sorts. It's certainly interesting looking back, and it was certainly an interesting company. It was successful. Otherwise, they wouldn't have lived that long. But now back to our more modern days and age. We have feedback and questions, of course, this week as well, because people have sent that to us, and you should do that as well for the future episodes, otherwise we run out. Send this to feedback@bsdnow.tv, otherwise this will be a very empty section and will be very sad. Because it helps people, we always get that feedback. It's not just original person asking a question, but also other people. Oh, I had the same problem a couple weeks, month, whatever ago, and so they also benefit from that. The first is Alan this week. Not our Alan, but another Alan with just one L in the name. Wait, you're also with one L in the name.
No, I have two.
Okay, so it's a different person.
Alan with one L was nice and spelled my name correctly.
Ah, yes. Oh, yeah, he made that distinction.
Being a fellow Alan, he probably understands the pain of people randomly putting the wrong numbers of L's.
Ah, yes. For me, it's the K in the Benedict. Mostly the US people and Canadians get it right, but the Germans always write it with a K.
Right, yeah. The K is uncommon on our side.
Yeah.
But I'm guessing in German, the K is more popular, isn't it?
Probably. Or even worse, if people write it with CK, then it's really off. But back to the question. Alan writes with one L. Hi, Alan with two L and Benedict. I really enjoy listening to your podcast. Thank you. I first started using FreeBSD sometime back in 2016. Now that I'm retired, I have more time to study the operating system. Can you please explain to me what the following terms mean? Upstream and head. Thanks so much for all you do for our community.
Okay, I'm going to explain them in the opposite order because it'll help. So head is how we refer to the very newest development branch of FreeBSD. So basically, we have a tree of the releases, right? So you have so there's a head branch, which is this basically constantly moving forward line of the operating system. And that's where all the new code goes. Then at points, we will branch that line and say start FreeBSD 11, and then a couple of years later, FreeBSD 12. And then the FreeBSD 12 version, we sometimes will merge stuff from head back into 12, and that's what MFC means, merge from current or merge from head. It means copying a new feature from the development branch into the release branch. So head is the name for the part of the repo where we put all the new code. So this is the very cutting edge. Like, if I make a change to FreeBSD today, it'll go into the head branch immediately, and people can download that and use it. But it won't go into a release for somewhere between a couple of months and up to 2 years. It can also be called the master branch, especially if you're using the newer Git terminology, or just current it means the same thing. So it's just the part of the branch where all the new code goes, and then once it's proven to be stable, sometimes we copy that code into the releases or other branches of the tree. So upstream can have two different meanings. In the one case, it is, like, for example, ZFS is some code in FreeBSD, but FreeBSD didn't write all of that. There is, in fact, this other project called OpenZFS that's writing ZFS, and then we copy it in. So sometimes we get newer code from upstream because it's like literally a stream and a river, right? We're a downstream fork. So the river comes along and then it forks. There's the original path and then our path. And so new stuff that happens in ZFS often happens upstream and then flows down the stream into our river. Then the verb version of upstream is actually when FreeBSD, if we make an improvement to ZFS, like the Z standard compression work I did, and we send it back upstream, basically, we take the code and send it back to the other project so that all the other downstreams can also use it that way. Or, for example, the in-kernel TLS that we talked about last week's episode, that was developed at Netflix and then upstreamed into FreeBSD. Netflix consumes FreeBSD, but they also give stuff back because it means that when they want to update their copy of FreeBSD to a newer one, there are fewer differences, so there's less chance of conflicts and stuff, and it works better for them, and it means everybody gets access to the code they did. So I hope that helps it make sense.
Yeah, that's... Sometimes we just use these terms and don't explain them because we think everyone knows about them.
And some of it is a bit confusing.
Yeah.
Especially, when you use upstreaming as a noun and a verb.
Yeah.
And when you use it as a verb, you usually mean it in the opposite direction of when you're talking about it as a noun.
Oh, right, yeah.
If there is an upstream, they're sending stuff to you. And upstream, the noun, is where you're getting stuff from. But if you were to upstream something, that's actually when you made changes to that external project and sent your changes back, which is the opposite direction.
From your standpoint, yeah. Yeah, very good. Continue with your FreeBSD exploits, Alan, with one L, and the other Alan as well. And so, yeah, thanks for that question. And if you have future questions, then don't hesitate to send them in. Rodriguez writes, "Hello, Alan and Benedict. You guys asked for some feedback, and I have some." Perfect. Thank you. I would like to say that the 2 episodes, 309 and 310 and 311, Benedict had sounding echoey, or as if the channels were mixed down to mono. Yes, we know about that. Sorry, that was an error on my part.
Yes, Benedict selected the wrong microphone when he was recording.
Yeah, so I have that fixed now, and I will look at it to make sure before we record that's the proper one. So sorry about these.
Yeah, and so we do record only in mono, just because our microphones don't really record stereo properly anyway. But yes, the problem was actually that he was basically using his laptop microphone instead of the one in front of his face.
Which has a much lower quality and is further away. So that's not the proper one. So sorry about that. This episode will be definitely using this one I have in front of me. But he also has a different question or comment here. I have a question as well. I've attempted to connect to an open wireless network with a captive portal for which I have credentials for. However, on FreeBSD, I try to connect using only the command line tools and I'm unable to. It would attempt to connect then fail, not even giving me the captive portal. Any help would be appreciated.
So the captive portal isn't going to pop up automatically. You have to fire up Firefox or the browser or something to get the captive portal. And so you're unlikely to have much luck with that on the command line. But if it's never associating with the network, that's likely a different problem. How are you trying to connect with just command line tools? It can depend there. Although for an open one, it shouldn't be too bad. In general, I use WPA_supplicant, which is part of the base system. Although in a graphical interface, I usually install the PCBSD-utils-Qt5, which includes a nice graphical Wi-Fi manager that basically writes the WPA supplicant config for you and has worked very reliably for me for the last 5 or 6 years.
Yeah, hotels have that often, these captive portals, or train stations or airport lounges or airports.
Yes. Without a GUI, getting through the captive portal can be difficult. You can install a text-based browser like Lynx, but a lot of the captive portals contain all kinds of silliness and might not actually work.
Yeah, they don't understand the text browsers necessarily. But yeah, you need to actually do some extra steps to make that portal disappear or appear and then disappear, hopefully, not getting in your way of browsing. Okay, so that's this question. And the last is Jeff with OpenZFS follow-up and FreeBSD adventures. Oh, it sounds nice. So, hi Benedict and Alan, he writes. I was catching up on back episodes last week and noticed that my feedback from episode 303 was read in episode 310. So I felt like I owed you guys a follow-up email on my progress with regards to the OpenZFS port. Oh yes, excellent. I remember this one. In the episode, you asked what I was trying to accomplish with the build world and build kernel steps. And the short answer is, I had no idea what I was doing, to be honest. Despite my past dabblings and strong POSIX OS familiarity, I'm still very much a FreeBSD noob. Oh, that's fine. So I went back and installed a snapshot from August 15th on a 12 stable and started over, installing the source tree that came with the snapshot. I created a new VirtualBox VM, so as to have something easy to set up and tear down, to do the testing. Successfully compiling the OpenZFS port and kernel module, I'm able to reboot and verify that the OpenZFS.ko module is loaded with KLDstat. I can see and import the ZFS pool that I created after the base OS install. However, I'm still stuck behind or being unable to mount the ZFS pool at boot, which puts me back where I was before starting over with a fresh install. I have a feeling that there is still a step that I'm missing.
So if it's failing to boot, what is the error, or failing to mount, what's the error message? I guess the most likely thing that it sounds like there is in your rc.conf, you need to have ZFS_enable equals yes, which basically runs ZFS mount-a to mount all the file systems at boot. If you're actually getting an error trying to mount them, I'd need the error message.
Or if you're at the mount root step,
then it wouldn't be booting.
Yeah, then it wouldn't find the proper data set to start from. However, he was determined to make this work, so if for no other reason than my own edification and BSD education. I have recently resurrected my old PC case with a new Intel Atom board and would like to make a home NAS system with BSD. I have long been intrigued by the advanced features of file systems previously only available on BSD operating systems such as Hammer and ZFS. Although I'm very impressed with the utter simplicity of Dragonfly BSD, the expanding multi-platform support of ZFS and software collection of FreeBSD felt like a better fit for my potential use cases. I realized that I could accomplish what I'm wanting to do with the ZFS included by default with FreeBSD, but something about OpenZFS intrigued me. Is there a timeline for when OpenZFS would be considered production ready? Thanks again for the great work you do on the podcast, and thanks also for the patience with the new guy.
I don't know that there's a timeline exactly. We're hoping to relatively soon get it upgraded or integrated in upstream, which will make it much easier to maintain and so on. Yeah, it's hard to say. But the more people that can take time to test it and beat it up, the sooner it will be.
Yeah, sometimes things are discovered in the last minute and you don't want to ship that bug. You want to fix it first, and then you need to test it on the other platforms as well. So that stops the release or putting it into more people's hands earlier.
Do you remember the German guy we interviewed who had done a bunch of work on just automation stuff or whatever at a company that was using a bunch of BSD stuff?
Yeah.
Do you remember his name?
You mean Patrick?
Yes, that's it. Patrick, German guy.
Yeah, Patrick M. Hausen, that's his name.
He pointed out that currently the OpenZFS port in FreeBSD, I think, didn't compile properly on i286, mostly just because of some compiler warnings about the printfs. He had found the problem because when he was saying it wasn't working, it was like, I just compiled it today. I was working fine. It's like, oh, i286, okay.
Okay, but at least someone is trying it.
Yeah, and likely the fix to that one is just an extra compiler flag to make it not complain about the mismatch between the printf symbol %LU and what the size of that is on i386 or whatever. But, it goes to show that nobody had tried it yet.
Yeah.
Because, nobody had told anybody that it didn't work yet.
You should, give more testing. Yeah, okay.
But, at some point, it's not going to get the real testing until it's the built-in version and people have no choice but to use it. But we'd like it to be good before that.
As good as possible to leave a good impression. Yeah, I think it needs more time in general to be. It's production ready at some point. It's been used up till now, but the new features need more work to be integrated in all those systems now. So that makes it take more time. Because it's not just need to work in one system, but in the others as well. There's the test suite, of course, but these are complicated systems, and a lot of layers need to be passed, among other things. But I'm hopeful that it will be finished before the year is out. And since there's no timeline, we can't say more. Watch this space. And that's a good closing statement, I guess. We'll thank you for listening to this episode, as always. And if you have something, again, send this to feedback@bsdnow.tv. And then we'll see you, or you listen to us, in a future episode.